Accurately forecasting hurricanes has improved over the past few decades through the use of satellites, NOAA's airborne hurricane hunters, and numerical weather prediction models. But with warming waters and the potential for an increase in major hurricanes, every bit of data helps. That's where sharks and their dorsal fins might come in. Hello, and welcome to USA Today's The Excerpt. I'm Dana Taylor. Researchers are studying sharks to see if they can gather and transmit useful data regarding ocean temperatures. Could sharks, long feared, be poised for an image makeover? Here to dive into the deep end on that is Carlisle, a University of Delaware marine ecologist who is leading the initiative to tap sharks to aid in predicting hurricanes. Thanks for joining me, Aaron.
Thank you for having me.
What led to your research on potentially tapping sharks as roving hurricane scouts? Why did this seem feasible?
So I'm not the first person to think of this. This idea of using animals as ocean sensors goes back maybe 10, 15 years, and they've been used on elephant seals and sea turtles and various air-breathing animals. And so the general idea is you put these devices on these animals, the animals swim around the ocean doing their normal thing, and the whole time they're collecting data that whenever they come to the surface gets transmitted to orbiting satellites. What we're working on is trying to develop the tagging technology to miniaturize this tool so it can go on the dorsal fin of sharks. And so this has been an active area of research for a while because people have known about the utility of this. What we're trying to do is there's a new generation of smaller tag that we're kind of helping develop and test out. And so the idea is eventually we'll have a fleet of sharks swimming around the world's oceans, beaming data back whenever they come back to the surface that helps us improve atmospheric models, climate change models, hurricane predictions. For our particular project in the Mid-Atlantic Bight, it's really about the hurricane predictions, but this is really about tool development.
Are there things that sharks see or sense in the ocean that our most advanced weather satellites can't pick up on? What kind of data are you trying to get?
Yeah, so the big limitation, remote sensing, satellite-borne sensors looking down at Earth have been a game changer in everything, but they're still limited to only seeing the skin. And so the ocean, they see the surface temperature, but they don't see what's going on below the surface. And for hurricanes, for example, it's all about the ocean heat content in a certain bit of water. So if you go from the surface down to the bottom of the ocean, how much heat is actually in that? And so satellites don't tell you that. So you have to send out manned platforms like ships or robotic platforms to do these kinds of data collections, which are generally very expensive. Or you can potentially start to use these animals and let them just use their natural behaviors to help benefit us and help us better manage the planet and our climate models. And particularly, again, for our project is coastal resilience in the face of hurricanes. The big thing that sharks do that satellites don't do is they dive underwater. So they come to the surface and they dive down deep. Many go very, very deep, thousands of meters into the ocean. As they dive down, the tag is collecting data. And then when they pop back up, it transmits it. And so again, it doesn't require anyone to be involved. Once you put the tag on the animal, they're out there swimming, collecting data, and you never see them again.
And you developed these devices. How do your shark sensors work?
So they basically, we're collaborating with a company in the UK. It's Sea Mammal Research Unit in St Andrews University, Scotland, and they're the only company that really makes this kind of tag currently. And so the tag is the one we're using is a miniaturized version of ones that have been going out on elephant seals and these other animals I mentioned earlier. But the tag basically is just a little computer that you stick in. It's a waterproof computer that measures depth and temperature, and it has has a GPS, basically like a receiver on the top of it, and a couple other kinds of sensors that basically are just turning on and off as the animal's moving through the water column, collecting the data in a way that is most effectively used by our integrated ocean observing systems, which is what we really use to collect data and put them into these big models that we use for predictions.
Aaron, there are lots of different types of sharks. Which are best at relaying useful hurricane formation and tracking data?
That's a great question. That's actually been a big part of this project is investigating that exact question is how do you figure out which shark would actually be a good candidate to carry these kinds of tags. And so generally what we look for is animals that dive. We don't want an animal just sits at the surface because it's not diving up and down through the water column. And we want animals that spend enough time at the surface with their fin cutting through the surface. When you think of Jaws, Shark Week, when that kind of iconic image of a shark finning through this dorsal fin cutting through the surface. Whenever they're doing that, that's an opportunity to transmit. get those data from that tag. And so basically what you just want is an animal that's moving up and down through the water column and spends a bit of time at the surface, enough time where the satellites as they're orbiting can detect the data that the tags are transmitting and sending out into space, basically hoping someone's there to hear from them.
Have you noticed any behavioral changes in the sharks after they're tagged? Do they seem unaware they're toting a device?
Well, I mean, from our perspective, it's hard for us to tell. I think they certainly know because it is a device, but the devices and our all these kind of tagging efforts are really predicated on the idea that these devices have minimal impact on the animals because we want them to be healthy and happy and doing their natural thing. And so it's still an active area of research, and there's always we're pushing the envelope every day, trying to improve how these tags are designed to reduce the potential impact on the animals. But it's minor, and we go through a very extensive animal care permitting process to make sure we're doing everything in a very humane and sensitive way. But yeah, we don't really see a lot in terms of whether they behave very differently. But generally, these kinds of interactions with sharks, once you catch them, anytime a person interacts with a fish, it's going to be kind of annoyed for a little while. And so, usually, when you put these tags out, you discard the first day or two of data because the animals are kind of recovering and getting their feet back under them, basically. So, but we haven't really been able to observe that yet, and that's largely because this has been the we're still kind of in the early days of this. We're just starting to really put tags out at scale this year, and so we're still learning a lot. And so every time we put a tag out, we're learning something new about how to improve how it works, how we program it. And so this is an iterative process, and we're still very much in the early days, but everything is heading in the right direction. So we're pretty excited about it. Yeah.
Tell me a little bit about the planning phase, what that looks like before you set out to clip a sensor on a shark's dorsal fin, and how you weigh the ethical responsibility of working with endangered species like mako sharks.
So we actually go through a very extensive permitting process through what's called the Institutional Use and Care of Animal Committee, IACUC. And so we go through this permitting process where we basically have to jump through a lot of hoops to show that what we're doing is going to have minimal to no impact on the animal and do everything we can to make sure that it's done in an ethical and kind of humane way. And so for makos, for example, they are on the threatened list, but generally these tags are small and they all end up coming off after months or maybe a year at longest. And so the idea is this is a short term, it's kind of like a bit of jewelry that the animal's carrying around for a little while, but it falls off eventually, leaving them to go about in their happy way. But yeah, so that's a huge concern that we have is really trying to minimize because everyone who works on with these animals are very passionate about them and we don't want to hurt them. And so we do everything humanly possible to make sure that these animals are impacted as little as humanly possible.
Okay, Aaron, how does your team safely carry out this work of locating these sharks, getting them equipped for hurricane tracking? Have there been any surprising challenges?
Yeah, well, every time you go out in the ocean, there's a surprising challenge, really. And, some days you go out and the animals aren't there. Sometimes you go out and there's too many animals there. And sometimes the animals are feisty and sometimes they're very relaxed and calm. But it just depends. Every animal's its own unique thing. But generally, we go out and we fish for them using the approaches people have used for decades. And we quickly basically pull the animals next to the side of the boat or the back of the boat, and we put a tail rope around the tail, and then you basically string it out along the side of the boat or the back of the boat. And once it's kind of tightened up along the side, it doesn't really do much. And so gets very calm. You can oftentimes roll it over onto its side or back. So it goes into what we call tonic immobility, which is like a state of paralysis that these animals go into when they roll them over. And then we have our team kind of jumps into action like a pit team, and everyone collects the data we need, collects the samples, get the tag on as quick as we can, and let it go. And this whole process usually takes, 5, 6, 7 minutes at longest.
Is the data you're collecting being used to inform current hurricane predictions? I know you said it's the early days. And also, has it been difficult to convince the scientific community that this method can work?
So the yes, we were hoping that we would have the tags available on hand to put out for this season, and we've been able to put out a few. But again, because of some of these issues I mentioned, programming issues, there was some battery issues. We haven't got a lot of data, so we aren't at the point yet where we're actually ingesting these models or these data into the models that we want. So the idea is hopefully next hurricane season will be the time that we really test out how this whole process works. Because the general pipeline, it's like the sharks surface, they transmit to the satellites beam back to us. We get the data, we process it like in real time, and then we ship it out to the end users. And so that's going to hopefully be happening this next hurricane season. This year, we actually just got blown off the water. We were out offshore, 100 miles offshore or so, in this wonderful research vessel called the RV Robert Gray, which we got access through the Seakeepers Foundation, which is a great foundation that helps scientists get access to large boats we can't normally access. And we spent about 4 or 5 days kind of offshore and looking around for sharks, but no luck. There weren't any around, but we certainly got very beat up by actually Hurricane Aaron, which was kind of ironic. Our trip we had to call it short because of the hurricane.
Are you hopeful that if people come to see sharks as a first line of defense in protecting us from the devastation of hurricanes, we may come to value sharks as protectors and not see them solely as predators?
Absolutely. And that's a big part of this. And one of the reasons I'm very personally excited about this project is I'm really kind of a shark ecologist at heart. That's what I've been doing. And so it's really satisfying to be able to work beyond just basic science questions about why do sharks do what they do? Why are they important? How do we conserve them? To actually saying, hey, let's show people that, understanding what's going on out in the world's oceans can actually really have very tangible benefits to society. And so by turning these animals into tools that will help us improve our own health and safety and sustainable management of ocean resources and ecosystems, you get this added benefit of like, look, animals, if you let them do their thing, can actually help us a lot. And this kind of is a call for like maintaining the health of our oceans, because if the animals are not healthy, then we can't use them in this way.
And I have to ask because I can't imagine doing the work you do. Was there a moment when carrying out your research felt like a mix between science and a Jaws-sized adventure?
Yeah, well, that's why we all get into this kind of work, is it's a lot of fun. It's really hard, and it's oftentimes very brutal. Like, you get beat up at sea a lot. The animals, their tails are the part you worry about, not their mouths, really. But it's very, very exciting. But like every kind of project and every kind of work, it becomes routine fairly quickly. But so at the end of the day, we go out there and we do this, and we have these interactions with these large, amazing animals, and that's half the fun. But we do things in a very, very safe way. Safety is always our primary concern. And so the general idea is if you're having like exciting moments, you're probably not doing something right. And so, especially because we're so far offshore, often we're very safety conscious, and we don't want anything to happen to us or the sharks, but us, especially because we're way offshore and it takes a long time to get back if something happens.
You'll have to forgive me, I refuse to believe that it could ever become routine. What's next for you and your colleagues, Aaron?
So we're going to just keep pushing this forward. And so one of the things we're trying to deal with is getting additional funding to kind of continue this effort. So NOAA, the National Oceanography and Atmospheric Administration, and the National Marine Fisheries Service funded this work. And it's basically was to develop this tool to help obtain ocean observations around the world. And so it's really this kind of idea is this can become a toolkit that organizations use globally and use sharks because, again, marine mammals and turtles and air-breathing marine vertebrates are generally endangered, really hard to access. In some places like the mid-Atlantic bight, they aren't super common, whereas sharks are everywhere and very little permitting, and generally most of them are not threatened. And so by targeting your efforts in certain species, you can turn this into a real tool that has the potential to really change our ability to really predict where hurricanes are going to go, and learn a lot about the way the ocean and atmosphere and weather works in general. But so our next effort is trying to keep this going and trying to really demonstrate the utility of that. And so this is going to be a long-term ongoing process that takes probably years. And a lot of that's just the learning process of how to do it. And so we're focused now on getting these tags out and just learning as much as we can from every time we put a tag out. And again, we're hoping that by next spring, we'll be ready to kind of have this whole framework ready to roll in a much larger scale where it actually will be providing useful data to the management agencies. And now clearly we're having issues with, based on the federal government and reduction of NOAA personnel and everything, where we hope the data will still be useful and can be ingested. But, that's something that we're going to be continuing working on to overcome.
I live in Florida, and I so appreciate you working on this. Thank you so much for taking the time to join us on the Excerpt, Aaron.
My pleasure. Thank you very much for giving me the opportunity to talk about our work.
Thanks for watching. I'm Dana Taylor. I'll see you next time.